Howdy, this is the video for Chapter 3, the chapter on vectors. Most of the quantities that are dealt with in this course are vectors. Almost all the powerful laws we are going to develop involve vectors. The quantities introduced in the last chapter, velocity and acceleration, are vectors, but we did not need to know that because everything was along a line. Life does not take place on a line. The quantities force, momentum, torque, angular momentum, these are all vector quantities. The fact that they are vector quantities is indicated by the arrow over the symbol. You may have learned about vectors in high school and may be learning about them now in your calculus class. Although you may think you are expert enough to skip this chapter, that would be a very bad thing to do. It is absolutely necessary to master a few vector operations, or you will have great difficulty with the subsequent material. When students are failing the course and finally show up for help, one of the most common reasons for their failure is their lack of expertise with vectors. You will need to easily write any vector in terms of its components and unit vectors. There are other ways to write vectors which mathematicians may find more elegant. That's their problem. For physics, it is better to define unit vectors I and j. To be able to express a vector A of given length and direction in terms of its components, a sub x and a sub y. Most of the time, we will only worry about two dimensions. Make sure you understand that the components are not vectors. Later in the course, we are going to introduce another set of unit vectors, and in engineering, you will use a third and fourth set. If you are an expert with one set, you will find it easier when faced with other sets. You should treat these unit vectors as your friends because they will be extremely helpful when you have to solve problems. So the first thing to master is writing a vector in terms of its components. The only trigonometry you will need is the definition of the sine and the cosine. At the risk of insulting anyone, let's just recall that for a right triangle, cosine of theta is the adjacent over the hypotenuse, the sine of theta is the opposite over the hypotenuse. Some of you write on your paper Sokata, which I thought was some Indian incantation, but it stands for sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. Once having mastered components, you will be able to simply find the sum of two or more vectors by first writing each of them in components. Since later we are going to spend a great deal of time on Newton's second law, which involves the sum of all the force vectors acting on some object, knowing how to find the sum of vectors is crucial. Problems 1 through 3 and all the exercises deal with this process. Expect to have a number of quizzes on such problems. It would be a pity to mess up some complex problem because you could not express some vector in terms of its components. A final word of caution. In the book, all vector quantities have little arrows over their symbol. It is a good habit to develop yourself. Every time you write the symbol for a vector quantity, put an arrow over it. If you see an equation that has an arrow on one side and no arrow on the other side, it will immediately scream that something is wrong. We learned in elementary school that apples can't equal oranges. In fact, they are both fruits. But no way can a vector equal anything except another vector. You need to master the techniques of expressing any vector in terms of components and unit vectors, and knowing how to add vectors. These are necessary in order to understand the rest of the material in the course. Don't leave home without it. Make sure you can do every problem and exercise at the end of the chapter. Gig 'em.